Hello everybody. I'm Rob from Italy, and I'm a solution architect and the CTO for Retailer. And today I'm gonna talk to you about platform as a service, containers, and scalability. Okay, just let me 1 second to share my slide. Okay, 3, 2, 1, go perfectly. So. Feel free to post your questions in the Q&A chat, wherever I have a monitor on that. So feel free to interrupt me. I will be happy to reply to you directly during the presentation. Okay, what I'm gonna show you today. As you see in the first slide, the initial session was about machines. Okay, a couple of years ago, I made a proof of concept of another service in Azure called Batch that actually creates many virtual machines on the fly to perform huge computations, and it worked great. But after some thoughts, I realized that we could do this even with less friction with containers. Okay, so today we are going to see how to implement a real scalable solution of computing with containers created on the fly that runs in CPU-intensive workloads. Okay, in this case, in the case of the demo, I will live code everything from scratch, so you will see the starting point and the ending point. So, what I mean when I talk about heavy workloads, I mean something that needs CPU time. So, for instance, if you have to process an image, to stretch it, to resize it, or if you have, in our case in Retailer, we have to parse unstructured document to get insights. So, for instance, just to give you a benchmark, for a single document, for a average CPU, we take around 1 second of computation time to perform the result. Okay, so this can be called a CPU-intensive workload. But if you deal with machine learning, with some other computation technique, you probably will need a GPU that's pretty the same. Okay, not the same, but it's the same approach. Okay, so you need the computation power. From the other side, you can have memory-intensive applications. So, for instance, if you need to push on memory, to put on memory some huge data set to work on it, okay, because the volatile memory is so fast, you need much more memory to perform this kind of operation. At the other side, we have IO-intensive workloads. For instance, when you need a good bandwidth, a good network connection to the third parties to perform your work. Okay, in this case, we are going to work with a CPU-intensive workload. Okay, the scenario is the producer. It's an assumption. The scenario is a queue-based scenario. So if you are accustomed with queues, with message-driven environments, event-driven environments, in this demo, in this session, we see a message broker that keeps incoming messages, and another consumer that will take the messages and perform a computation on it to produce the result. Okay, the third part is not made in this session because of the time, because it's really useless. Okay, as I said, we should assume that the consumer part, so the real processing part, should take around 1 second to perform the operation, okay, and release the message. Good. What we want to do is to scale out to a huge number of machines. So I mean machine, but I said machine, but I mean containers. Okay, I mean nodes. Okay, so try to abstract it. I'm a real fan of platform as a service. That's the part of cloud computing that gives us some services hiding the underlying complexity of the management, of the governance. So when I say platform as a service, I mean storage that you don't need to administer at low level. I need compute that you don't have to connect to virtual machine, manage a Kubernetes cluster, and nothing of that. Okay, so platform as a service is those kind of services that you just connect, use it, and then throw away if you don't use it anymore, and just paying what you are using. So when you heard a couple of years ago, 3 years ago, the buzzword serverless. Serverless is actually an evolution of platform as a service. Okay, so today we are going to use technology that is called Azure Container Instances. This is actually containers serverless. Okay, so the real good transition of platform as a service. So those are the only slides I have. So let's start. Let's go straight with the demonstration. Okay, I'm going to create a few lines of code. I know that probably is out of the scope of this conference, but just to start from scratch. Okay, I'm interested to show you that there is no hidden complexity in this demonstration, so I just want to start from scratch. Okay, completely the blank page, and for that I will need to write some lines of code. Then I will provision some resources on Azure, and I will run the workloads on the Azure container instance. Okay, and finally I give you some tips around the creation of multiple instances with some scripting, with some templates, with some YAML. Okay, actually. Good. So this is the Azure Portal. I hope someone says before. I'm creating a service bus that's actually a message broker, that's actually the counterpart of if you use RabbitMQ or something else. Okay, the service bus is the Microsoft-owned technology for message broker. It's AMQP compatible, so you can also use it from other application. That it's not proprietary. Well, it's proprietary, but the protocol, the supported protocol is standard. Okay, so DevOps Pro Europe run. And this is my resource I'm going to create in Western Europe. Okay. And the second resource I want to provision right now is a container registry. Okay. As you probably know, containers are images. Well, the container should be at the instance of an image. Okay, the image is just the definition of that container. Okay, and that images are stored somewhere in the cloud. In this case, in a registry. Okay, the most common and the most famous public registry is Docker Hub. But we can have also private registries for private images, of course, for enterprises that have private deployments. And I'm going to create a kind of resource of that type. So registry, container registry, yeah. And I'm going to call it DevOps Pro Europe run.azure.io. I will select this SKU, but it doesn't matter the SKUs, the pricing tiers, it's just out of the scope of the session. So let's go straight on the default settings and clicking create. Okay. So in a few seconds, I also have this container registry ready. Okay. Container registry and service bus namespace. In the service bus, the talk around service bus could also take hours or days, okay? But what you have to know for this session is that in the service bus, we have two kind of entities. The queues, okay, first in, first out queues. Many producers can write a queue, many consumers can take the messages from the queue. And the topics. Topics are the technology that enables the publish and subscribe mechanism. So one or more publish and we have multiple subscription with rules and something really even complex. Okay, but just to simplify, we are going to use queues today. So I'm just creating a queue that is called to do. Okay, very simple, and I will write the message in this to do queue. How? With .NET. Okay, this is my primary language, and I will connect to the service bus with a shared key. That's one of the authentication methods that I can use, and I will write some messages. Okay, so let's move to Visual Studio, and let's create a console application. Okay, so DevOps Pro Europe. Oh, nope. Okay, that's good. Producer. I will align the latest version of .NET Core, that is not called a .NET Core anymore, just .NET, again, .NET 5. Okay, I will use a library just to put some constants, some settings. Okay, so loop count. And here I would add the dependency to the service bus library. As I mentioned, I can also go to the service bus through AMQP, but I'm not have time to do that in that way. So I'm using the managed library. So with 2 lines of code, I'm going to write the messages into the queue. Oh, if you see here, we have the dependencies of AMQP. So under the hood, the library uses that. Okay. Okay, good. I do not need this. I'm referencing this one to this. Okay, why I did this two projects? Because I'm going to write the producer and I'm going to write the consumer. So I want just to include some common stuff into the common project. So the dependencies and, for instance, the connection details and nothing more actually. Okay, so let's go straight. So new producer task. Let's go and generate this. Okay. Create a public async task method. Run async. Okay. And prepare the code. Okay, good. Here I'm going to use the queue client. So new queue client, that is actually the object, the class that let us connect to. Let's choose the proper overload. Okay, connection string and the queue name actually, and the receive mode. Well, actually this is the producer, so we are not interested to specify the receive mode, but I'm just specifying because of the second part of the demo. Okay, so now we are needing the connection string details. I'm putting them here in the appropriate class constants. Okay. It's not the preferred way to hold secrets, okay, just for the demonstration purposes, okay? Public static string SB connection, and same for the queue, SB queue. Good. The queue is to do, while the connection is here. Okay, good. And let's specify this into constants. Connection. Sorry. Let's be clear. And now we have a method to send async a list of messages. Okay, what we want to send to the queue, well, it doesn't matter. Okay, we can just send IDs, okay, random IDs or GUID. Okay, so let's prepare a bulk of messages. So let's say messages is enumerable. Let's get range of 3K and select a new message that is the proper data type to be sent to the service bus. Okay, inside the message I can specify a body represented by a byte array, so I can start from a string and I convert it to a byte array. So how to make the conversion? Through the encoder. So let's keep the UTF-8 encoding, and let's say get bytes of a string. And which string? We can get a GUID, GUID. Oh, well, hold on a second. I'm gonna crazy with the keyboard. Okay. Okay, good. So we have now a list of message of 3K messages, and we can say qc dot send async messages. We can also do this a couple of times just to have a bunch of messages. Okay. Okay, something like that. Okay, let's note this. So sending messages count messages. Okay, and let's run this stuff. We're just preparing the messages right now, not consuming them. Okay, sending. In the meantime, we can go here, go to the queues, go to this queue, and see that, okay, messages are arriving. Okay, so it's okay. Good. Okay, it can be good. Like 1,000 messages, it should be okay. So now we are going to create the consumer. Okay, good. Consumer. Because it's so simple. Okay, so pardon if I write some C# code in this conference, but it's just to start from scratch, as I said. Okay, so new consumer task. Okay, we can take the same approach here. We can take also the same approach of calling it, but in the consumer, we have a difference. Okay, we specify the connection. It doesn't work because of the .NET version. Okay, and now it should work. Good. Let's include the usings. When I press Control and point, it's a shortcut to add the using directives. Okay, so it's just a Visual Studio that helps me to write code in a more efficient and faster way. Okay, so now we need to receive the messages. So we need to register a message handler. Okay, so a lambda that takes a message, a token, and for instance, we have a message, the token, and the body. And here we need a message handler option. To manage the exception. We don't want to manage the exception, so just say that's okay in case of exception, but we need to say autocomplete. Why? Because in messaging technology, when a message is taken from the queue, actually in most cases is just take from the top and put in a hidden state for a period, for the lock period. Okay, why? Because in messaging system we need to ensure the at least delivery. So if someone fails, for instance, during the execution of the job, the message will be re-enqueued to be reprocessed again. Okay. So if you don't complete that message by sending an acknowledgement to the queue, you are going to reprocess the message so many times. So since we don't have time to complete the message in an explicit way, I prefer to say autocomplete. So every message that I take from the queue is automatically acknowledged for the completion. Okay. Here I would say that this is async. Okay, and here I can take the message content. So content is the message, the body, encoding UTF get string from that body. Here receiving content, and that's all. It's not necessary to make this async. So should be no. Okay, that's good. So after that, just to avoid the function to stop, we can make a while true and sleep or a task delay of 1 second. Also, to simulate, okay, the fact that the single message will take around 1 second to be processed, for instance, if we have a complex computation, a CPU-intensive workload, we can also put the same weight here inside to perform the simulation, okay, to see that the consumption rate is just 1 message per second. Okay, let's run the demo. Okay, I think it's working. Okay, it's working, and it's dequeuing one message by one from that queue. So the actual rate of consumption is just very, very simple, is 1 message per second. So now we need to span this workload on 100 of nodes, okay, of compute units that or containers. Okay, so let's create a Docker file here. So new item, let's see, text general text file. Okay. Docker file 60, just Docker file. I'm specifying to copy it in the destination folder. It's not the only way to do this, just a simple way to demonstrate this. Okay, in this Docker file, I will post a sample from my second screen. So I start from this image that is Debian, the Buster Slim with .NET runtime installed already. And the entry point is the name of the DLL produced by the build. That is the same of the name of the project, so dope consumer. Okay, let's hit build, and let's go to see the file system here. Boom, that is produced. Okay, so some libraries and executables for Windows, and the DLL, that is the entry point of the application. Okay, so now let's go with the Docker part. So Good. Docker build with the tag, with that tag. Okay, so let's come back to the Azure Registry. So the Azure Registry is DevOps Pro Europe run, but we never log into it because we just created it few minutes ago. Okay, so let's enable the admin user. Let's take the key and let's log in. Login DevOps Pro. Pardon. Okay. DevOps Pro Europe run.azure.cr.io. DevOps Pro Europe run. Password. Okay, that's it. So Docker build with the tag DevOps Pro Europe run.azure.cr.io/consumer. What the content of this folder. So it reads the Docker file, download the images, to create all the stuff, and after that we make a brief test of it. Okay, so Docker run this. Okay, it's working. I think it's working. So now we have the container pushed here in the remote repository. No, sorry about that. We need to Docker push the image. Just a second. Okay, good. And now we want to deploy it. So we create the third resource of this demo. So ACI, in Italian, ACI, Azure Container Instance. And what's that? Okay, think about a Kubernetes cluster, okay, with some unused resource, okay? Think about the capability to borrow that resource pool from someone else and to use it serverless. Okay, Microsoft is doing this kind of stuff. Okay, they have multiple Kubernetes cluster and they give them to us in the serverless form. So I'm just specifying the place, of course, the container name, consumer test 01, which is the image to start from, so this one, and the target of CPU and memory, so from 1 to 4 and until 16 gigabytes of memory, and in case also the capability to attach as a GPU. Okay, in this case it's quite enough for me. I can specify a network endpoint in case of a container that has some incoming endpoints like the HTTP one, okay, or a TCP endpoint. In this case, just a workload, just a batch process, so it's not needed, okay. Finally, the retry policy. So what I want to do in case of a failure, so in case of the container exit with an error code, I want to restart it. So good, this policy is good. Or do nothing. Or always restart. So even in the case of a gracefully shut down the container, restart it. So I'm just keeping this default rule that it's okay in most of cases. Okay, create it. And this a kind of magic, because in few seconds we have this object, this artifact that wraps the container image in an instance and it runs. That's it, without orchestration, without any infrastructure, without any cluster, without nothing, okay, with nothing. So let's go here. Let's make an F5. Just a few seconds. I told you seconds. I think about half a minute, okay, 30 seconds to create the container. So find it in another way here. Okay. Okay, it's running on Linux. This is the container, it's been pulled from the registry. Those are the logs. We can also connect to it. Okay, that's all. When we finish, we stop it, and the billing is stopped too. So we are just billed for the seconds that the container is running, and it's the other killing feature, in my opinion. Okay. So with one container, we didn't achieve the real scalability that we need to have, okay? So when you go back to the service bus namespace, if you count some messages processed by my machine and some other messages processed by the container on, okay, we have just 3, well, where is running? Here? Okay, I don't know where it's running right now. Probably it's still running in the container instance. But, well, it doesn't matter. The rate is a few messages, okay, per second. Now we need to scale it in a huge way. Okay, how to do this? Let's go back to the container instance and let's export the creation template that it's used under the hood by Azure to provision this resource. Okay, so let's add it to the library. Dope template. Okay, that's good. I hate to provide the mandatory descriptions, and I'm going to edit the template. Okay. Let's edit the template to say, okay, we have a parameters that is the container name. So let's just call container name and replace the parameter name here and here. Then the default value is, well, not specified, just consumer. Okay, well, dope consumer. Type string. I want to have another parameter that is the container count. So the instances that should be created on the fly. Okay, default value 100 and type integer. And let's go here. Well, I want not a single resource, okay, but an array of resources. Okay, how to do that? Okay, there is a specification in the ARM templates of Azure. Here, for instance, one of the properties of this resource can be a copy property. So copy, and here I can specify okay, the name of the copy, and so ACI copy, and the count. The count is actually taken from the parameter. Okay, so there's a specific syntax that is parameters and the name of the parameters. Container count. Okay, good. And good. Then the actual name of the resource cannot be the same for each copy, because in that case there should be a conflict. So if the Azure tries to create a container and then container and then container, will raise an error the second attempt because of the name already existed. Okay, so here we can say that the name should be the concatenation, for instance. Okay, concat of what? Of the parameter container name, then a dash, and then, for instance, the index of the copy. That is a variable, not really a variable, a method, copy index. So I close another parenthesis, I close this one, and it should be okay. Good. This is the name of the internal container, so it doesn't matter. This is the image to start from, and those are the credentials for the registry. The password is missing, so I'm going to paste the password here. So let's take the password again from the registry. Okay. And I think that's all. Let's save it. And now let's deploy it. So let's deploy here. The name is okay. Container count. Let's just perform a test with a couple. Okay. No. I made some mistakes here. Yeah, it's not so easy to write all the code correctly. Okay, 1, 2. Okay, just to be sure. Okay. I pasted it from my reference, from my dry run reference on my second screen. Now let's see the progress, and 2 container instances are creating. Where? In the same place, in the same resource group here. They are already running, and they are dequeuing stuff. Let's refresh it. Oh, it's just in a waiting state. Waiting state means that the container is not yet pulled from the register. So in the meantime, let's deploy other hundreds of templates. Just a second, because before I edited in the deployment part, so it didn't take the actual code in the template, but just in the creation part. Okay, so let's fix here too. Okay, let's deploy consumer here, production, 100 of containers. Okay, let's wait a few seconds more. Okay. This is not good, but well, just wait some seconds more. In the meantime, we can see the logs. Okay, so everything is being dequeued. Okay, and the instances are quite okay. Each one is running. So let's go back to the queue system, to the service bus namespace here. And we can notice a huge amount of messages processed from a click to the next one, okay? Because of the huge parallelism that is performed by these hundreds of containers in parallel. And I provision it that in a serverless way, okay, without any Kubernetes cluster, without any complexity. So that's all. So let's come back to the presentation. So just to make a brief recap, we implemented from scratch a produce-consumer solution with a fake consumption logic just by waiting a second. We deployed it to containers in a technology that is called Azure Container Instances, and we create an ARM template to perform a multiple deployment to 100 containers at the same time to consume the messages in a faster way. That's all, and I'm here for the chat for the question. I see the first question. So in this demo, you're adding. Just a second, I will move this on the main screen. Okay. In this demo, you are adding container instances manually. Okay. Can you make it automatic and based on other variables? The queue, okay, scale out. Okay, perfect. The question is from Alexander. Thank you for the question, Alexander. Well, you can do this in a couple of ways, 3 ways probably. That the most common ways are. You already have a Kubernetes cluster, and you can configure the Kubernetes cluster with the virtual pod engine to spawn automatically to Azure Container Instances when you have no room for your containers, when you have no resource to allocate to your containers. So this is the preferred way that Microsoft suggests. So just to hold the spike of unexpected compute resources that you might have. The second way is with KEDA, for instance, that can be triggered by some external events, okay, and can spawn new Azure Container instances. The third is, of course, with a custom coordinator. So we use a blend of custom coordinator not to create them automatically, but just to start them. Because if they are built on a second basis, okay, you can have them deployed, pre-deployed, also 100 is not a problem, and you can start them on demand. Okay, so when you start them, they perform the work, and when they finished, you can also implement just the retry policy in case of failure only. So when they are finishing to the queuing stuff to perform their stuff and they end, automatically they are stopped and the billing is stopped too. So this is the third way that we are using that is quite effective. I hope I answered you. Otherwise, feel free to chat and I will refine my answer. Okay. If there are no more questions, that's okay for me. I thank you very much for being here at this session, and feel free to contact me, search me on Google and send me an email or in the channel you want, and I will be glad to give you some tips and support on it. See you tomorrow. I have another session about data. Okay, so the JSON power inside a relational database, that is SQL database, even on the cloud, so on Azure, in a platform as a server way. So same approach, same ideas, but on SQL database and with the format that is well known, that is JSON. So thank you very much, and see you tomorrow.